I'm Josh Starmer from
Woohoo.
the YouTube channel StatQuest with Josh Starmer.
And I'm Luca Antiga, CTO at Lightning AI.
And together we're going to talk, together we host the AI Buzz, where we're going to talk about the latest trends in AI and just talk about why they will change everything, or if they'll change everything, that we might get a few of those as well. But anyways, to get us started, I just want to mention that yesterday I have a friend in publishing who's an editor at a big major publishing company, and he came up to me and he goes, Josh, will ChatGPT put me out of work? Will I lose my job? And I feel like that's
Wow.
a good question. Luca,
Good
do you
question.
have an answer for this?
Oh, not at all, of course. No, I don't think so. Well, if anything, it will make it more challenging for people to compete against boilerplate, right? Text and uninteresting stuff. But it will empower people to produce more content. It also will empower people to produce more marketing stuff to target us mindlessly. So, I mean, we're going to pay, all of us are going to pay for it. So, but, I don't think
Yeah.
so. Of
So
course, things are going to
what I was
change.
thinking of,
Yeah.
I think one thing that ChatGPT will be really cool and helpful for is, say, like, I want to write a book about, say, I just started writing a book about neural networks, and I could say, hey, ChatGPT, give me an outline. What should I write about on neural networks? What topics should I cover? And it might give me a nice outline, get me sort of like in the ballpark, maybe speed up a few steps of brainstorming. And then what I can then go in and do is flesh it all out and, make it uniquely StatQuest and draw my little pictures.
Yeah, exactly.
But I think it'll help. I think it'll help with like the brainstorming and sort of just getting started. There's that blank page like disaster that we have whenever I try something new. Like if I'm going to make a new StatQuest or a new song or a new book or whatever, there's that blank page that you're like, now what do I do? And I think it'd be awesome that now we can just say, hey, ChatGPT, get me started.
Yeah, for sure. For example, this show, right? I didn't know.
Yeah, exactly.
Like we had to find a name for it, so we wanted to find a name that sounded cool. So I went on ChatGPT and said, "Hey, ChatGPT, can you tell me a name of like 5 names of a show?" What I say was on the lines of what's the name of the Daily Bugle? I say something like the Daily Bugle, something.
Okay.
And it's spat out like 5
That was
names,
your
and one of them
query.
was the
That's how
buzz.
you got it started.
Yeah, exactly.
Yeah,
Uh,
I love it. So, Luca, I was just talking about how you used ChatGPT to write the lyrics to a song. Can you tell us about that experience?
Yeah. Well, I was like at a friend's. I'm helping him record a few songs and so on. And so he wrote a song, and I wanted to come up with alternatives lyrics and actually the melody for it. But I had like 10 minutes because I needed to start working. So I got onto ChatGPT and I said, okay, can you generate a song with this vibe? And then it got something to me that was really cheesy. So I said, a bit less
Uh-huh.
cheesy and a bit more, blah, blah, blah. And in a few iterations, I was there. And so, and I produced something that I meant with the
Uh-huh.
kind of ambience that I meant to obtain. And it would gotten me like a lot more time. Probably I wouldn't have gotten it there if it wasn't for that tool. So, I mean, the potential for it to empower people to, maybe, write a song if they want to and experiment with it. It's really great. What's
Yeah.
interesting is that you can give it instructions back, right? And it will adjust things the way you want, but keep the structure the same. So this kind of long range relationships between things where I don't know if you know how ChatGPT works under the hood, Josh, like roughly speaking.
No, I don't. That's the thing. Yeah,
Yeah.
that's I'm here to ask dumb questions. You're here to help us understand.
No, no, but that's
So
what
tell
just an
me,
excuse to
how does
start
it work?
speaking about it. It was, I know you know better. But let's say that so how ChatGPT works. ChatGPT is a model that is fundamentally it's a GPT that has been conditioned to do a chat, as the name says. What
Okay.
is GPT? GPT is a short name for Generative Pre-trained Transformer, which is a very fancy name
Okay.
for a model that is not super easy to understand fundamentally. But you can write it up in
Yes.
like 300 lines of Python. The crazy thing about
Okay.
that, and then of course the code that OpenAI has there will be much more complex, but the complexity you layer on top of it is mostly to scale it up to be huge, right? So it's more like
Okay.
incidental complexity, but the actual computing model that is there is really compact.
Yeah.
Is a very simple model, and of course it's trained. It has like billions of parameters. It's trained in a very particular way. GPT is pre-trained on a massive amount of data, but then it's fine-tuned to behave well, to behave in a way that is like amenable to interaction with people, with a technique that is called reinforcement learning through human feedback, which is like
Okay.
as it denotes, it means that um, another model was trained to kind of rank the output
Yeah.
of the bigger model and say, okay, this is
Yeah.
better than this one. And so humans sat
Okay.
there saying, oh, this output is better than this one. And this output, and they did it
Okay.
not just with two, but with a bunch of them. And using something that is
So that
called,
was a.
yeah, go ahead.
I'm just curious. So what we're saying is at this stage, they had humans sort of curate the output and rank the output.
Yeah,
And that went back into like the back propagation and the training of the bigger model. Is that correct?
that went into training a model
Mm-hmm.
that was called the reward model that then was used to um, improve the parameters of the larger model.
Okay.
And
And the
so
reward model,
yeah,
the reward model was somewhat, had human interaction and human grading. Is that am I
exactly.
getting this right? I
Yeah,
might be getting it all
yeah.
wrong.
No, it's good.
Okay, good.
So he learned to
Yeah.
rank things in a
Uh-huh.
similar way as a
Yeah.
human would do. And incidentally,
Oh, so
ranking things, saying if something
yeah.
is better than something else, is easier than generating it. As we all know, right? You can tell if a good is better than
Yes.
another one, according to
Yeah.
some preferences, but you can maybe write the same book or the same grade book,
Yeah.
right? So it's kind of the same kind of relationship. So,
Yeah.
and this is how ChatGPT got from great to really, really impressive in
Yeah.
interacting with humans.
So can I ask a few more questions about it? Um,
Yeah.
so it's generative. And so far, at least on my channel, we've had very simple neural networks that just make really basic predictions, like a really simple output, yes or no. It's this type of, iris, or it's, the drug's going to work or it's not going to work. How does the and I understand that, but how does the output for a generative model work?
Yeah. So it's funny because these kind of models are trained on a task that is fundamentally very simple, which is predicting the next word. So
Okay.
the astounding thing about these kind of models and large language models, in this day and age, is that they're trained on tasks that are very uh, granular. For example, given a
Yeah.
text, you mask a word and you try to fill it in with the right word. Or you need to predict what comes after a series of words, and you would have to understand what
Sure. Sure.
that I was trying to say
Yeah.
words. And this produces models that are able to make connections between different parts of sentences. They understand understand the structure of reasoning to some degree. Actually, there have been papers that have shown that large language models perform when they see a prompt, which is like the text I ask a question with. There are many ways of asking those questions, and they perform a sort of gradient descent themselves in answering those questions. So they are capable of learning algorithms through which they will then generate the text. So I mean, it's almost like, and we will talk about that. Like then we will recap the conversation, and we'll get onto kind of a program of what we will discuss in the future. But essentially, it's almost like we, as a humanity, we have stumbled on a new form of expressing computations that is capable of learning, that is very simple, but it's capable of learning very difficult things. It's almost like when, humans from Roman numerals, humans in Rome, whatever, or in Europe, and in other parts of the world, they got from their like clunky numeral systems to the Arabic numeral system that allowed them to kind of supercharge their ability to reason about things, right? So it's almost like that.
Suddenly, you can suddenly do math that's like useful instead of just like adding two numbers together. But can I ask a really quick question?
Yep.
So when we're going back a little bit, talking about the generative models, is that a little bit say like someone sends me a text on my phone, and my phone already has like a suggested words, and could I ChatGPT is basically that, but like really well done. So instead of like actually typing in words, maybe I could just hit the select, the suggested word, and just keep hitting the suggested words, and it'll say something reasonable and sort of apropos to the conversation. And I will not have. I'm really bad with texting, so this actually sounds really great, right? That I could just like hit one big button like 4 times, and it would do a whole sentence instead of like. Is that a little bit how ChatGPT does this auto generation? It's basically it completes a word, and then based on the word that it's predicted, it says, well, this is probably the next word, and based on that word that it's predicted, it goes, well, this is probably the next word, and it just sort of like does the prediction like that. Is that sort of how it works?
Yeah, it's how it's trained to work. But then out of the sudden, like there's this emergent behavior of understanding relationships that are very complex. For example, in the text that it just generated or that you provided to it, right? So it can do calculations, it can produce code. I did some sort of interaction, right, where it says, I started with some code, and then I said, okay, eliminate the variables that are useless, and it did it. And then I said, what if those variables are torch tensors? And it did it. And then I asked, can you turn this Python code into Python bytecode? And it did it. And then,
no way.
Changed the addition into a subtraction in the bytecode, but not in the original code. And it did it. Like it's really, it's not just text completion. It's not like, your usual thing. And you can do pretty much the same, not just with ChatGPT, right? If you go, like many large scale models today are capable of doing similar things. And we are seeing that a few of them are being released in the open. But of course, the more you tune them, the more useful they will get, because people will have to think less about how do I prompt this model, and they will just get the right thing out of the box.
So I have I have another stupid question. I apologize, Luca. So when I was in college and I took a computational theory course, and they were like, you know, we talked about Turing machines and
Yeah.
things that could be solved with Turing machines and
Yeah.
things that could not be solved with Turing machines. And things that could not be solved with Turing machines were like those were like problems that we needed entirely new types of computers for. We needed quantum computing. We could not solve these with a standard computer. And one of those problems was like understanding code. You know, even though code is so structured, and it was a long time ago since I took this class, so I could be wrong, but I just remember coming out of that classroom thinking that I guess we'll never, in my lifetime, we'll never have a computer that can really understand code. And basically what you're saying is that we're actually doing that right now, and that is within my lifetime that we're seeing these things.
Yeah.
How is that possible? Are we like defying physics? What's going on?
Yeah, the strange thing is that I don't think we fully understand how that is possible, right? We have a very vague understanding on how these things work. Yeah, I mean, a few people in the world have a better understanding, better intuition. Then there's a bunch of us that kind of grasp it somehow. But you see papers in which they like start doing like reverse engineering on what happens, right, within these models.
Yeah.
And I mean, it's in a way it had to transcend the human comprehension, right, in order to do this, because this is like a very hard problem. And if you could write the rules that allow you to do this, it would be inherently an easy thing to do somehow, right? Like if you remember the Jeopardy thing, with IBM and Watson, that system was a system that was built on rules, right? A large part on rules. So it was a very big expert system, and the thing there was like a lot of knowledge went into it, a lot of facts, and the facts were processed in a way that then it would generate like there was probably of course some probabilistic stuff in there, but ultimately at the end of the day rules were very prominent yet. But then to break that complexity, and a lot of years went into that, a lot of engineering, and time travel 20 years, and we have like a few hundred lines of code potentially, right? With a few algorithms on top of it, that plus a lot of engineering to scale up to massive. But the fact that the computing model is so simple is something that is really fundamental. And I think we'll talk about that in future episodes, hopefully with a better internet connection. Okay. So basically, I think we'll try to look into what fundamental computation GPT is doing from a computing model, because the fact that this model has come from sequence modeling and the terminology that we use, attention and so on. I don't know. I have a very maybe it's a very uninformed position. I don't know. But I think it's kind of shadowing a bit. And there's a nice paper, Thinking Like Transformers, it's called, that kind of talks about what computing model transformers might be presenting to us fundamentally, right? And how the computation works inside them in order to actually learn not only sequences but actual algorithms. And zero-shot abilities. When we talk about zero-shot abilities, are abilities that they weren't trained on, and they just you gave them instruction and they can execute the instruction that you gave them at inference time. So it takes a lot more than just predicting the next thing in order to be able to do this from a computing standpoint. So it's very fascinating. Yeah. And the other big thing that happened this year is diffusion, right? And no, image generation, and now we're seeing sound generation. So in future episodes, we'll get more into those tiny bits here. One of the interesting things here is that the same mechanism, attention, has been injected into what makes Stable Diffusion generate images, which is an old model, UNet, which is a model that is basically a kind of a hourglass model, but it's usually drawn with a U, and it has a few skip connections, but it was published back in 2015. I remember reading the paper when it came out and trying it out on 3D medical images. But the fact that then they added attention to it, I think it made it so powerful. And of course, the whole diffusion framework made it so powerful. But in the end, there are commonalities between all these models in the sense of this fundamental computing block.
And that fundamental computing block is?
Well, the attention mechanism, which is something that it needs to be a bit, digested and explained and understood.
Yeah.
And so the other interesting thing, I think, when we talk about, these models is the fact that they're, like, as we said, they can be expressed in a few lines, right? And so when you express them in a few lines, that's where innovation can come in, right? Because you developed, you can develop like a higher level intuition for what's going on. Whereas if you have a very complex repo in front of you or a code base, then doing something, manipulating that something becomes a lot more complicated. So something that I've been enjoying is Andrei Karpathy's Nano MinGPT and Nano GPT implementation. You can go on GitHub, Karpathy, Nano GPT, and GPT there is 300 lines, and we'll get more into it maybe in the future. But essentially, this model scaled differently. You give it a lot more parameters and so on. It's what is powering ChatGPT that we started from. And everything else is an incidental complexity due to scale. Now, of course, you can have a more like efficient attention block, blah blah blah. But from the core principles, that is the architecture, right? So it gives me the opportunity to understand the value of eliminating boilerplate, because if you can express that same model and make it run at scale without any kind of complexification, then when that is when innovation comes in, right? And so since you're wearing the Lightning t-shirt, that's where I think we're focusing on boilerplate, right? And try to remove it from everything, like we did it with the trainer, doing with the apps, and doing with distributed computing and so on. Because eliminating boilerplate is a factor that enables scientists, not AI experts, to use things on one end, but also AI experts to kind of stop caring about all the incidental complexity and focus on the thing that actually makes the magic happen.
So I guess one question is Luca, you were talking about this book, Thinking Like a Transformer, or this essay, or can you talk about that a little bit? What does it mean to think like a transformer?
Yeah. So the thing is about the attention block that we talked about before, right? So this piece of, neural networks are made of like simple computations repeated a lot of times, and like a typical neuron has a linear component and then a nonlinearity right after it, like feed-forward networks and so on. Like attention is a bit different in the sense that when you get an input that is composed by many elements, they don't even need to be a sequence. Like then you can make it understand that the thing is a sequence with a particular encoding, but there's nothing to it that really, is inherently a sequence. And so when you have an attention block, basically you pass your input into something that will figure out how to weight, to assign weights to the input elements, and in order to produce the next thing. But these weights are generated in a way that it resembles like the ability to store information depending on the input, and then you retrieve what usually happens when you have that input and how you combine it with itself to generate those weights. So, for example, if I have 1, 2, 3, 4, and every time I have 1, 2, 3, 4, I want to obtain 1, 3, 2, 4, then probably I will want to say that the 1 will remain a 1. So you will weight, let's say you will generate like, you will take the input sequence itself and say, okay, I have all my, if I am the 1 at that point and I see the rest of the sequence, I will get the diagonal element over an imaginary matrix that has the sequence n itself on the two x and y axes. And if you want to switch the 3 and 2 and obtain 2, 3, 3, 2, then you will take the 2 and say, okay, when I have a 2 here in the second position, usually I get I weight a lot in my output sequence. I weight a lot the third element in my sequence. So by creating weights this way, so evaluating the input sequence itself, this is where I can draw nonlinear relationships between the input and itself in a way that can be stored in a matrix and learned. And this happens over and over again because you have many ways of composing the same sequence with itself stored in your quote memory.
Okay.
And so we'll get more into it from a mechanistic point of view, but basically learning these 2D matrices and the way they you can combine something with itself or something with something else, because you can condition a signal with something else. For example, I can condition an image from text the same way with this 2x2 thing that combines elements together. So these mini cards that tell me how to combine these two different axes, and I can populate this card with numbers across the card, are what makes the attention mechanism exist essentially in the way that it is today. So it's like a 2x2, I don't know, and it's not 2x2 in reality, it's many more dimensions, but ideally we will see from that paper that it's really close to learning nonlinear relationship by learning how to kind of exchange information between two different sources. And that can be the sequence in itself or a sequence in something else. Unfortunately, I don't have the camera up, so I'm mimicking things and nobody's looking at me, but
yeah.
Yeah.
I guess, so, I mean, what I'm imagining in my head is, so like you were talking about with a normal neural network, what we do is we pipe things through activation functions. And as a result, we get little bits of curves or bent shapes that we can then stretch, and we can flip them over, and we add those shapes and we add those curves together to get something that, like a squiggle or something like that, that fits to the data. But maybe what you're saying is that with attention, it's more like we're doing like a really like crazy hyperdimensional lookup table. That isn't necessarily a shape, more as it is like, given these inputs, that then can lead to sort of some nonlinear combination of those inputs and the weights that we've given them, can lead to sort of like digging into this hyper matrix or something like that of
Yeah, yeah,
picking out an output.
yeah.
Um,
It's very similar. Like it's not incorrect. In fact,
yeah.
it's not that you cannot express similar things with very deep, even perceptrons or standard feed forward.
Hmm.
The fact is that uh, you can learn much more efficiently. Like there
Mm.
have been some scaling studies that have demonstrated recently that have demonstrated that the original transformer architecture from 2017 was the best learning efficiency across the board of many variations on the theme, and this tells us and that um, the same, we were talking about Roman numerals and Arabic numerals. It's
Yeah, yeah,
almost like that, right? So the
yeah,
way the computation goes on inside those objects makes it easier to learn
yeah,
a lot of things.
yeah,
And it's not that you couldn't express the computation otherwise. It's just
yeah,
very effective to learn it
yeah.
that way.
I like that analogy. Actually, it's kind of perfect. It gets us all the way back to how we started, right? Because yeah, it's not that the old way couldn't do these things. It's just so much more work. Like trying to do long division with Roman numerals would just be the biggest headache ever.
Yeah.
Um, but instead, with Arabic numerals, we can do that pretty easily, relatively speaking, easily. And so of course we're going to be like, well, this way of notating or this way of representing knowledge is more efficient. So we're going to switch. And so it makes sense that, yeah, we would switch likewise in with neural networks and AI to switch to these things that can get to this answer like in half the time or in a quarter of the time, and then we can reach further, then we can go further, we can take them further and do things that we could have never really imagined that we were going to be doing with the standard neural network, because we knew, because they were slow and they were difficult to train, that we were only going to get so far. And now we can go like 10 times as far because we've got just a much more efficient way of training the model, which
Yeah.
sounds
And
fantastic.
yeah, it's great. Like, I don't know what the future will hold. Like, for us, like your
Yeah,
friends from the publishing company, for
yeah,
sure,
yeah,
the human-machine interaction landscape will change. I don't know
yeah,
if we'll be subverted or whatever. Probably not.
yeah,
But
yeah,
but for sure, it will have a multiplying effect. The point is ultimately is what tools you create for the people, right?
yeah, yeah,
To do more. Because
yeah,
if you have an API, probably you're not gonna succeed.
yeah,
Yeah, GPT-3 has been out in the OpenAI playground for a while, but it's only when ChatGPT got on the stage that like my brother-in-law started talking to me about ChatGPT, right? And he's
exactly.
a tech guy, but he is
Yeah,
like is not directly interested, in this topic. But now he started playing with it, right, in with the
yeah,
family at dinner. So, uh, and for
so
example, like Microsoft today, the news
yeah,
from today that they will invest $10 billion and OpenAI with the idea of integrating that kind of technology in products like Excel and
yeah,
Word and so on is a testament to the fact that ultimately, right, you change life of people by
yeah,
delivering products that remove the kind of conceptual boilerplate of doing things, and make
yeah,
them faster ultimately. So yeah, I mean the product creation aspect. So I'm excited not because these things will take over, but they will allow us to create products. For example, how many times, Josh, you have reorganized your folder of notes and changing the nesting structure of how your notes were taken.
Oh yeah,
For
yeah,
example,
all the time.
all the
Exactly,
time,
all the time.
there's
Yeah,
no right way to do that, right?
yeah,
There's no right way to organize our knowledge. But if you had something that was maybe fine tuned on your style that could kind of summarize your notes and have the main takeaways organized for you, and
yeah,
then maybe the next day you ask them in another form, and you don't have a problem to deduplicate things and so on. And you can
yeah.
do it without even thinking about it. That's when your life would change for the better, right?
Luca, I just have to say, you just blew my mind because, I mean, totally blew my mind because I mean, I suddenly realized that the way I organize my folders and whatnot is a little bit like attention, in that it's, I'll start doing one thing and, and it grows, right? And all of a sudden I need to add some hierarchy to things, and maybe I need to rename these files. What started out being one thing ended up being another thing. And it's really only when I have the full context of
Yeah,
like all the work I've done that I really see how to organize it. And it's almost like language translation with attention or whatever, where it's only when you see the full sentence and you process it all kind of simultaneously rather than one word at a time that you can get a really accurate translation, and that
yeah,
words that start at the beginning of the sentence can then affect how things are at the end of the sentence. And it's like, and I was like, oh my gosh, yes, we could apply that same sort of mentality to my notes, and how they're structured and how they're organized, because it's really only when I'm kind of done adding to them that the actual structure becomes apparent. And so you just blew my mind right there pretty hard.
no,
And
I'm looking forward to it because every note taking application I got, like I always, drop it at some point because it becomes something
no,
that I don't like anymore. Because
I
I probably don't
I have a
like myself so
confession.
much at that point.
I have a confession. I use
Oh,
scraps
nice.
of
Look at
paper, and
that.
I use both sides, and that's my strategy is lots of
Yeah.
scraps of paper all over the house. So, with that said, we're going to wrap up today's episode of the AI Buzz. Thanks everyone for coming. It looks like we had over 1,500 people drop in during the live stream, which is pretty awesome. Anyways, with that said, we'll be back in 2 weeks to talk about more. I think we're going to dive more into ChatGPT, more into transformers, more into attention, more of all this stuff, and hopefully we can we'll get Luca's audio working just a little bit better. So, anyways, I just want to say goodbye. Thank you for being here for episode 1 of the AI Buzz. Yeah, there's Luca. So giving them thumbs up. Thank you very much. I'm really excited. I think we're gonna have a lot of fun together. And hooray!
Thank you, Josh. It's been great.